Okay, so let's walk through this scenario together. So we've got these beetles, and they vary in their coloration, and you can see that in the forest areas they're mostly brown, 90% brown, but in the lava fields where it's black, they are mostly black, which might seem obvious to you. Well, duh, they'll blend into their environment. But there is one key that has to be there. Okay, so your hypothesis is that they're blending into their environment, but why? Why are they blending into their environment? Well, in this case, there must be a predator or something that selects for that color, so it benefits them to blend in. Let's say they were being hunted by snakes, and the snakes were doing it by smell or sound, then it wouldn't matter what color they were, and you would not expect to see those differences in coloration between the two areas. So it must be that there's a visual predator in both areas selecting for the ones that stand out. Okay, so that would be a good hypothesis. And so in this case, then it says in 17, if a predator was introduced into the area that hunted beetles by their movement rather than their color, then like I was saying before, you wouldn't select for color. Now, if we're starting though with 90% brown in the forest, 90% black in the lava, would you expect it to change? Would you expect it to then go back to like 50-50? This is something that students always get tripped up on, and they think that if the selective pressure is taken away, because that's what's happening here, we have a predator that's hunting by movement, so it doesn't matter if we pull that pressure away, does it somehow reach an equilibrium? And the answer is no, right? Hardy-Weinberg always predicts that it won't change from whatever it is. Like if there's only 2% of this particularly weird allele that kills you in the population, and then all of a sudden we cure it and it no longer kills you, it's not like it's going to become more frequent. It's still going to stay the same. So in this case, you should predict that it should still stay 90% brown in the forested areas and 90% black in the lava fields. Okay, so then it says, all right, we've got this new volcano, it erupts, it decimates the lava field populations of beetles. So in the next 5 years, we're being repopulated by the forest glades. So you would expect right after that, when all of the lava field beetles are destroyed and we have these other beetles coming in, you would expect them to be mostly brown, right? This is gene flow, they're coming in, they're mostly brown. But then over time, over these 5 to 10 years, these brown ones are going to get picked off by whatever visual predator is still there, and you're going to end up shifting back to the mostly black populations.